Okay, Wiz, I heard RAG is dead. Is this true?
Super dead. Never been deader.
100%.
You should never try RAG again. Sorry, folks. It's over.
Yeah. Okay. All right. There we are. We have it. That's practical RAG. I think the R in RAG stands for retrieval, right? And so like people are still retrieving stuff today, I think is my understanding. Is that right? It's kind of a
They
big
do
part
be
of business.
Yeah, they do be retrieving. Yes, that's that hasn't left us as a core core philosophy in how we build AI applications.
That's right. Or yeah, really kind of all sorts of applications. It's the problem Google's been solving forever, the retrieval problem. And then plugging it into an LLM. Well, now we're in the age of generative AI. RAG isn't going anywhere, it seems. It's sort of becoming more and more table stakes all the time. That kind of led us to really wanting to do this event. RAG is more mature than it was 6 months ago, more mature than it was a year ago. People should be thinking about it. It's not just for people on the edge. It's not just for startups. It's for enterprises too. We're seeing it everywhere. We should be seeing it everywhere. If you're not doing it yet, you should be doing it now. This is the point of today's event. Anything to add?
I mean, there are a number of things that people say are killing RAG. Long context is killing RAG. X, Y, Z is killing RAG. The thing that I hope comes away or you go away with after this event is that those things are good, but they just don't sit where RAG does yet, right? Like it's like, yes, we have Gatorade now, okay, but that doesn't mean we should only drink Gatorade and never take a sip of that sweet regular water, right? Like it is the case that Gatorade costs more, comes with a number of catches, right, that you don't have to worry about with our good friend H2O.
That's right.
RAG is kind of like water, right? It's just something we do that is effective. It's simple. It solves a problem that not everything can solve.
Well, hopefully we can pull a little RAG and flow like water through this event. I'm ready to kick off. How about you, Wiz?
Let's do it.
Let's go. All right, everybody. Thanks for joining us for today's event. We are excited to break down RAG for you. If you have questions along the way, please use the Slido link in the description box on your viewing platform. And if you're in the midst of a discussion we're having, go ahead and jump in to the YouTube or LinkedIn chat, and we'll go ahead and try to engage as best we can. All right, with that, everybody, let's go ahead and get into RAG, the 2025 best practice stack. And I want to kind of let you guys know, I wanted to make this part one because we realized we're just going to kind of run out of time a little bit. I think this is going to be a really great way to get started. If you're getting started today, whether you're an enterprise, whether you're in a startup, whether you're in Silicon Valley or anywhere else around the world, this is still the right place to begin. I'd like to actually make sure that we follow this up with a proper part two. People have a lot of questions about CSPs, cloud service providers, about how to, pick and choose AWS, GCP, all this kind of stuff. It's important to ask these questions, but we have to get to the core concepts and code at the bottom first, and then we'll be able to go ahead and have some of these higher level abstraction conversations that I think just won't quite make it into today. So part one, startup scale. Let's go. I want to align our aim to the day today by making it super clear what you're going to get out of this session. We want to tell you about our picks for the best orchestration framework, VectorDB, enhanced retrieval technique, evaluation framework, open source LLM and embedding models, also where we're going to host those open source LLM and embedding models, also how to actually look at operating this stuff and what we should start looking at as soon as we're hosting and serving some models, as well as hosting and serving our application. That's a lot. And so, that's kind of why we need the part one, part two. We're going to move towards part two, thinking more end to end. How do we deploy on the back end? How do we actually look at the front end? How should we be thinking about if we need to migrate, when we need to migrate to more powerful computing platforms, or I should say more automated computing platforms. All right. So with that, let's go ahead and start introducing this topic of RAG, properly before we start the discussions of the stack and get our first build going. And you guys can see exactly how it's done today with the latest and greatest tools. Okay, RAG, let's put this in context right now. RAG helps solve a very simple problem. Nobody wants hallucinations in their apps. This is, the apps are confidently telling you stuff that's false. And this is a question that people around the world, around enterprises, are asking. And you know, the answer is like, yes, the LLM is just going to spit out tokens. And so what do? We have to sort of fact check our apps. And the way that we do that is the same way we do it with people. We're saying, where's your reference material? What is it that you're basing what you're saying on exactly? This is the purpose of retrieval. So retrieval helps us find references. We then augment the prompt in context. We add those references to the prompt, and then we get better answers through our generations. So that is, we do retrieval augmented generation. A simple way to think about RAG is that we are literally just giving the LLM access to new knowledge that it was not trained on. You can think about this from an individual perspective. I'm going to give it access to my personal notes, my personal diary, my personal journal, my personal data. You can think about it from a company perspective. I'm going to give it the proprietary notes, the proprietary information, the proprietary customer data. And this is what we want to do. We want to give our applications access in a safe and secure way to the knowledge we know we need in our company and in our lives to make these kinds of applications really work for us. We like to break down RAG into two component parts. One is retrieval, typically done with dense vectors, although that is a bit more naive than some of the sort of super smart, more sparse methods you can use for retrieval. Retrieval is a bottomless topic. And then in context learning. And so when we think about fact checking with RAG and how this sort of applies to each of these, retrieval is done with these vectors. Augmentation is done by simply putting stuff in context. And the generation is really the kind of the RAG. It's where you've already done the retrieval and the augmentation, and you're doing the generation. Now, also interestingly, when we go and we find and we look for references, what we're using an embedding model. When we go and we actually augment the prompt, send it to a generator, that's where we're using what we typically think of as an LLM, the chat style model. So typically what we're going to have in a RAG setup is we're going to have a query, we're going to have a question, we're going to ask something. We're going to go to an embedding model, we're going to create an embedding representation, basically turning words into numbers here. Those numbers, if we have a vector, we can quickly search, see how similar that vector is to other vectors that represent other chunks of words from our data. Once we can identify the similar chunks, we can set up a prompt template that basically says, use the chunks I find in the context and don't lie to me. And then we can pump the chunks into the context. Now we're back in natural language space after heading into embedding space for that quick retrieval process. This is the retrieval that we're talking about. This is the in-context learning that we're talking about. And we're not quite done with RAG until we send everything to the generator and get our better answer. Now, importantly, this whole piece right here is about getting great fact-checkable input. And then we put it into the LLM. So you can see how important this big piece is right here and how much it has nothing to do with the actual LLM. Here's a helpful analogy that I hope is useful to some of you that have studied the transformer. You see, in the original transformer paper in 2017, we had a BART style or an encoder-decoder stack. With an encoder stack on the left here, this is a BERT style bidirectional encoder representations of transformers. On the right here, we have a decoder stack or a GPT style generative pre-trained transformer. So what's interesting is that when we use embedding models today, those are actually BERT style. And when we use chat models today, those are actually GPT style. And as in the original paper, we use the encoder to sort of understand the input. And we then took that understanding from the encoder and we plugged it in to the decoder. And so in the same way, we're sort of getting fact checkable input in a RAG system. We're kind of using it to understand the data. We're sort of using it to increase our understanding through this retrieval process. And so this augmentation that we're doing in context, as we augment what we're putting in context, that is like literally just putting into the prompt. This idea of in-context learning is from the original GPT-3 paper, so it was very, very well defined. It's just putting stuff in the context window, it's just prompting. Now, if you're not super familiar with transformers, we've recently released a great open source full course. We'd love for you to check it out on YouTube, and you can learn all about some of those details behind the scenes. The reason why it's important to understand that we're using the context window, that we're putting stuff in context, is that when we build applications today, the entire stack that we use is based on in-context learning. It's based on this idea of what are we putting into the prompt exactly, and how is it getting there? And that sort of upstream retrieval process is so important. And this is from A16Z, the LLM application stack. They put it out really almost, I guess, a couple of years ago now, but it's held on quite well. And it has 3 stages. It has embedding, it has retrieval, and it has inference. And I know this might be a little bit hard to read, but I think it's important to sort of map this in a couple of different ways for you guys. This sort of data pre-processing and embedding first stage is where we get the contextual data through our data pipelines. We use an embedding model. We have a vector DB. We're orchestrating. When we go and we actually construct the prompt, we might actually connect to external APIs. We might do some agentic stuff. We might actually also want to go ahead and host this app somewhere. We might want to make it easy for this thing to be updated and played with, sort of in context. But we're not going to really focus on that today too much. Also on the back end, we're going to want to make sure that we're doing monitoring, logging, taking care of validation and caching and all of the best practices we need for production LLM applications. Anyways, of course, we need to be hosting our API endpoints, whether it's LLMs or embedding models somewhere. Where is that? And of course, we need data. And, let's assume we have top secret data. We're going to sort of mimic this today because we know many of you basically have top secret data, and this is what you want to be able to leverage. And what we're going to do is we're going to walk through each of these. We're going to use LangChain / LangGraph as an orchestration framework. We're going to use LangSmith for monitoring and for observability. We're going to use NVIDIA's embedding model. It's quite good. In fact, we think it's the best today. And we're going to use Quadrant as a vector database. We think it is the best today. We're going to use a Llama model for Meta. Should be no surprise. 3.3 7dB Instruct Turbo. And there's also some other pieces to the puzzle that we're going to put in place. We're going to do hosting through Together AI. We're going to leverage Cohere for re-ranking. We'll also give you an open source option for this. And then finally, for assessment, we'll use the RAG assessment framework. So let's dig into why we chose these tools now and exactly what sort of sets them apart at this stage of the game in 2025. Wiz, I want to bring you up for this set of discussion points we have here. First, best orchestration framework, LangChain / LangGraph ecosystem. Is this really the real deal? I mean, I know they have kind of the most users, but is there another reason behind this?
It's just integrated well with everything, right? So this whole stack is basically reliant on the fact that, you know, there is not a correct solution for your exact setup, as much as there is a solution for the best place to start, right? And so as you're going to have different sources of data that need to be connected, through a retriever, as you're going to have X, Y, and Z, you get the idea, right? The power of LangChain is that it's the most flexible while still being a useful, tool. Specifically, LangGraph as part of the LangX ecosystem. I think that's the best thing. We're really focusing on things that will scale with you from 0 to X, and that's why LangGraph.
Yeah, I just want to double click in on this particular one once, because I heard that LangChain is stupid and it failed a lot of people. And if you Google this, you can find some articles, and I wonder, like, what's the perspective there? Why is that sort of something that people have written, but that we're now saying today, actually, I wouldn't worry about that?
A lot of that was written about very previous versions of the technology, right? I mean, like, we saw a lot of that coming out, especially, mid last year, I'd say, which is being written about LangChain pre v0.1, run 0.3. I mean, ultimately, LangChain is, here's the truth, okay?
Yeah.
You're never going to stick with whatever framework you start with, because eventually you're going to understand deeply why the application you need is existing, and then you're going to just slowly build it out in probably just Python, right? Whatever other language you care to use. So you need it to last until you're ready to do that.
That's right.
LangChain's going to do that for you every time, right?
It.
Especially now that they've built, it's better.
Yeah, it's better. They're tracking changes. They're not
Yeah.
breaking things.
That's right.
Yeah. So it's important to keep up with, like, today versus a year ago. And
That's right.
Even if you hear it at conferences, people say, "Hey, it didn't work. It's dumb. We tried it and stupid." It's like, yeah, when exactly was that? Because 6 months today in this space is like forever. So they're
it's
pushing all the
infinite time.
It's infinite.
Right.
It's
yeah.
infinite. And they also got their Series A earlier than all their competitors, and they've just literally been on a growth trajectory and velocity, as far as I can tell, that has outpaced everybody else. Okay, next up, we've got Best Vector DB Quadrant. So Quadrant was, interestingly, one of the few companies that actually raised money like this year, that as a vector DB company. Why do you like Quadrant?
I'm going to say this answer a lot, but Quadrant's great because it's good when you have 7 documents, and it's good when you have 7 million documents, right? So Quadrant is another choice that you can choose and you can just stick with, right, for its existence. Maybe one day, right, you get to the scale where you're like, well, we need to accelerate this with GPUs, so there's something you might want to change to, but while you're in that kind of sub billions of documents phase, things like Quadrant are just going to work blazingly fast. There's a flexible number of hosting options. Obviously, you can host it yourself, you can host it through the cloud solution, you can put it into whatever CSP you want. It is again the most versatile while retaining performance. If you have hyper specific use cases, you may not reach for Quadrant first, but if you have hyper specific use cases, you're already past the scale where this is a plug and play solution space. Right? You're into the weeds. You're going to be doing profiling on your use case in order to make these decisions. But for everyone else, Quadrant's just going to work the whole time, right? And it's going to be cost effective the whole time, and it's going to give you enough levers to really leverage the performance that it promises.
Yeah, and I just, I want to just make it clear to the audience here. It's like a lot of times I think people go and they try to build an AI app and they say, well, I want to put all my data in it right now. And their data already resides somewhere. So Elasticsearch or wherever it is, right? And first of all, like, don't put all your data in it first. Number one, all right, put exactly enough data. And yeah, you can use whatever you want. But if you're looking for a place to start and you don't know where to start with specifically LLM type applications, where you're not yet trying to connect it to all of your production stuff, you're not yet doing that. You're literally building it outside of that. This is our recommendation, right? I mean, there's a lot of sort of, but I want to do this, but I want to do that nuance that you can get into, and that we've certainly talked to clients about. But I just want to just double click in on that for everybody. It's there's no right answer for all situations. The answer is always it depends. This is the starting up from zero. Okay. All right, continuing on here. We've got best now embedding model. We actually chose the NV embed from NVIDIA, that this was actually kind of a newer release here, the Llama 3.2 NV embed. Tell us about this model and why we think this is the best today.
Again, I'm going to say this all the time, man.
Keep saying it.
This is another option that you can start with and finish with. Okay. First of all, it's not huge. Now, what this means is that it's not literally the best across all benchmarks, right? But it's 1B. It's not 7B, right? So it's still fast. It supports long context window, 8K tokens. It supports many different languages, right? Maybe your app is just English right now, but users that exist beyond North America are going to start using your app. You've already got a great embedding model. It is packed with all the features you would care for it to be packed with. It's lightweight compared to like the 7B or 8B alternatives. And it has multilingual support out of the box, long context out of the box. I mean, it's a good embedding model. Is it literally the best on all metrics? Of course not, right? Like you can just get an even bigger embedding model if that's all you care about, right? But if you exist in a space where you're making trade-offs between cost and performance, this model is the most, it's in the sweetest spot, bar none, right now.
Sweet spot. Love it.
Yeah.
Okay. Now let's talk, about LLMs too. This sweet spot idea maybe applies here as well. This Llama 3.370B. Of course, there are bigger Llama models, but you really want 400 billion parameters. You really need 400 billion parameters. Also, we have instruct tuned out of the box. That's something that's a best practice that we should go ahead and note for everybody. If it's not good at following instructions out of the box, you're probably going to have to make it good at following instructions. So just let somebody else do it first. Tell us about this model and why 3.3 and not 3.1.
Yeah, so 3.3 is just the new one. It's really good. It's good at all tasks that you would expect a RAG model needs to be good at, which is instruction following. It can also swing, pinch hit as an agentic model with tool calling. So as you explore more advanced options, you stick with the model you love. Llama's very well understood at this point, which means that the prompting strategies for Llama are pretty much locked in. Its capabilities are extraordinarily well explored, which means that you're going to know exactly where you're going to hit walls. I mean, it's also 70B. I feel like 70B is a sweet spot for people getting started. Yes, you could use 3.1, 405B. Yeah, there's bigger models. There's newer models. Everyone's got a model, right? You have things like, Google just released their closed source model. That's super good. Right.
Yeah, for sure. I want to go ahead and talk a little bit about the evaluation framework that we're going to use today, which is one of the best practice evaluation frameworks that you can find out there. This is from RAGAS, the guys at RAGAS. It stands for RAG Assessment. They were a YC company recently, and this was kind of an open source project that started to really gain traction. And the things that we noticed here at AI Makerspace were that the companies that were kind of building the orchestration frameworks, the LangChains, the Llama indexes, they started to build out their own evaluation frameworks. And really, it became something where it was more desirable for them to sort of focus on being end-to-end, building out their cloud capability, and letting a company that was super focused on developing metrics, really building that open source community around metrics, really driving that innovation around metrics, was something that could slot in and just plug and play right in. And so like, it really is clear that RAGAS is kind of pushing the limits, even now with agentic evaluation. And they've got some really robust RAG metrics, really, really great starting point. Again, if you know exactly what you want to monitor, and you know exactly what metrics, and you know exactly how you want to constrain outputs, and you got your application super dialed in, you maybe don't need all of these fancy metrics. But if you don't know where to start, it's an incredible starting spot. Moving on, if you sort of do that baseline evaluation, you say, okay, now I want to improve my retrieval process. I want to actually improve what it is that I'm putting into the context window. So Wiz, let's say I did the RAGAS thing, I got a baseline, and now I want to sort of improve. And there's tons of ways to improve. I can look at chunking. I can look at different retrievals, different retrieval techniques. I can look at, obviously playing with my data a lot of different ways and adding metadata to it. The thing that's just easy sitting there right out of the box is just to pick up a re-ranker, which basically says, take all the stuff I put in context and just re-rank it so that it's really most relevant top context is at the top, least relevant is at the bottom, maybe cut off n equals 5 if I'm returning 20, and just sort of, compress the stuff that I'm returning. Why Cohere re-rank? And then we gave an open source alternative. Why do we do that here as well?
Yeah, I mean, Cohere re-rank is the best one. So that's why it's there. It is cheap comparatively to other solutions. It is fast comparatively to other solutions. They offer kind of enterprise levels or tiers that mean that it can also be useful if you have data that you care about not being handled improperly. It's just like the best one. I mean, that's it. Like sometimes the choice is that it's right sized, and sometimes the choice is that it's just the best one, and it also happens to cost very little. Re-ranking is a very specific thing. Right sizing is more difficult than the other tooling options we have because it's like a hyperparameter. We provide an open source alternative because you may need to run this on-prem. You may not be able to reach out to things like external APIs, in which case the Llama 3.2 re-rank from NVIDIA, it's the same thing we said about the embedding model, but for re-ranking.
Yeah. Okay, good stuff. And then when we have these models, we need to, especially the open ones, we have to host them somewhere. And our hosting choice for today is Together AI. There's a lot of obviously like ways we can serve models and host them, especially in more production environments, especially at scale. But like, again, we're probably going to hear a similar thing from you here. Why Together AI? Why are we using this today?
I mean, because we can. Like, there's not really you're getting charged for all of these models, no matter what. This is a good solution because they have most of the models already available that we're talking about. If you're looking to host NIMs, it's different. If you're looking to host on your own hardware, it's all of this. All of these solutions are just going to cost you money. You're going to pay for GPUs. Whatever your favorite way to pay for GPUs is the correct answer here. Together AI just has the models that we're using. Yeah. So there you go.
Super easy to spin up. Very easy to get going. And of course, there's lots of ways to go ahead and host models. again, this is sort of the startup. Okay, finally, monitoring and observability. We're staying in the LangChain, the LangGraph ecosystem here with LangSmith. When you think about why LangSmith over other alternatives, people are all building out their sort of clouds, their end-to-end platforms, whether it's, Llama Cloud or from Llama Index, or, literal AIs building a platform, or even OpenAI. We're going to cover their sort of agent platform here, in a week or two. Why LangSmith today?
Because we're using LangChain.
I mean, easy.
I have in the notebook, if you're not using LangChain, you should use Phoenix Arise. Arise Phoenix. That's LangSmith is super well integrated in the whole LangX ecosystem. If you're using that tooling, you should be using LangSmith. If you are not using that ecosystem, Arise Phoenix is a great alternative.
Okay, awesome. So
Period.
Thank you for the wisdom drop on each of the picks today. Let's go ahead and tee you up for the demo. Got a couple more slides. We'll see you back in just a moment, Wiz. Okay, guys, so those are the tools we're going to use. And the way we can sort of visualize this is a few different ways. We can think about taking our RAG stack that we've got here, and we can think about how LangChain or LangGraph or whatever orchestration framework we're using is kind of gluing these things together. It's got its component pieces, its core constructs. These are LangGraphs, these are LangChains right here. And we're also going to layer in these other pieces. We're going to layer in the NV embed through together. We're going to layer in Llama 3.3 through together. We're going to layer in our top secret data. We're going to layer in our Quadrant vector store. During retrieval, we're going to do some re-ranking. We're going to do some assessment based on the answer and look at how exactly we're doing stuff, from a latency perspective, from a cost perspective, what things look like on the back end. We can also think about it, of course, in this context. Okay, so let's talk about the RAG app we're going to build today. We want to build this RAG app with your data. That's the way we want to imagine this. And the data we're going to use today is not your data. I'm going to take some potent quotables from Leonardo da Vinci, from Henry David Thoreau. Now, I understand the model was trained on public data. We're pretending this is private data. And the reason that we want to use something like this is to make a couple points really clear. Let's remember that as goes retrieval, so goes generation. If we get retrieval right, we do better at generation, and we do that through this prompt augmentation. Now, what gets chunked in our data, which we haven't really talked about yet, is what gets retrieved. And of course, chunking is just literally taking the text that I have and breaking it into small pieces. Quotes are easy to think about chunking. There's another layer to this. We wanted to use two authors because metadata is really important to think about. It's data about the data. And, the data about the data for us is like, well, who said it? That's the first piece. You could think about a second piece of data. Where is that quote from? Which book, which paragraph, which references use that quote? There's a lot of pieces of metadata one could imagine having these things be connected to. Now, why is that relevant? Well, think about your enterprise. Think about the pile of PDFs, the pile of Word docs, the pile of data you have, all the different databases. Think about how each of them are linked to each other one. Think about just a simple question, the pile of PDFs question. What document is this chunk that I just returned from? Let's say I took 1,000 documents, chunked them all up, threw it into a vector DB. If I don't have metadata about which doc each one was from, I'm not going to be returning that in context exactly. And so we can think about it in this sort of very simple case of what author was the quote from when we're doing this retrieval. And so the way to think about our raw source documents being chunked, putting through an embedding model, being stored in a vector, is that we have this chunking process and we have this retrieval process. And then we have this additional metadata that we want to then flow that metadata into the vector DB so that we can leverage it potentially, especially if we want to do some metadata filtering, which we're not going to really do today, but we're going to show that this is a really important thing. As the models and the frameworks and the tools become things that everybody has, they're not differentiable. Data is what's differentiable. How you set up your data for success is differentiable. That's the competitive advantage. Same thing as with ML and AI classically. Think about that chunking and retrieval are both going to affect context, and that metadata can be leveraged to optimize what we put in context. So finally, RAG being this in context learning and dense vector retrieval, really what we're talking about is we're just talking about information retrieval and putting stuff in context. Remember the stack that we use from orchestration all the way down to where we're going to host the endpoints. Now we're ready to build, ship, and share. Now we're ready to head over to the Wiz to see RAG, the best practice stack 2025. Wiz, take it away.
Oh, yeah. RAG practice 2025. Okay, so we're not gonna whiz through this. We're gonna kind of like take it reasonably. Basically, this is just gonna be a list of things that we want to do by default every time we do stuff. Number one, we're gonna be talking about the best practice, RAG tooling. We're gonna be talking about the ways to implement this, and then we're going to be expanding a little bit where necessary. First of all, we're getting all of our API keys. We're using the build.nvidia.com endpoints for our embedding model. We're using Together AI for our model. We're using Cohere for our re-ranker. So we have import or environment variable soup here. Then we're going to use LangSmith, of course. LangSmith is a visibility tool, extremely important. It lets us see what's going on. If you're not using a LangX ecosystem, I would recommend you to just straightforwardly use Arise Phoenix, which is an open source solution for this problem. Okay. Next, we're going to look at the ingestion of documents. You'll notice that we don't have a text splitter. No text splitters in sight. Okay. So it is not a best practice to use text splitter, right? It is not a best practice to rely on out-of-the-box tools for chunking your data. You should think about what your data looks like, and then you should chunk based on what that data looks like. This requires you to have an understanding of your data. It is just not the case that, recursive character text splitter for the win is what we're going to recommend currently. I don't, there is not a catch-all solution here. There is not a one button that you can press and it be good. Solution here, you must use your brain, basically, is what I'm going to say, in order to chunk things. When it comes to the actual, data strategy here, I think one of the things that people have begun to realize is that data quality is crucial for RAG in 2025. Okay. Period. No ifs, ands, or buts. That's just the way that it be. So you must understand your data. If you aren't a data scientist or you don't have one, try your best, use AI. But the idea is we're not just using recursive character text splitter anymore. Okay, so we have our data. It's all separated by double new lines, so it's easy. We split it up. We have 89 quotes from Da Vinci, and then we have 50 quotes from Henry David Thoreau. But the Henry David Thoreau quotes look like crap, right? There's like this one dot, weird quote marks, right? We don't want this stuff. Again, data quality is of utmost importance, right? So what we do is we build a cleaning function. It's just a cleaning helping function. All it does is clean. There you go. When we get to the final result, we see that all good things are wild and free. No weird stuff going on. You might say, well, like, why does this number matter? Well, because LLMs understand stuff, right? And if they see that a number is high, they might consider that chunk higher, even though it's not higher, right? So these kinds of things matter. That's why we clean it. There you go. Next is our embedding model. We're just going to use the NVIDIA AI endpoints with NVIDIA embeddings. We're going to point to our model. We're not going to truncate. Truncating basically means that if it exceeds the context window, it is useful to, instead of throw an error, just return the stuff that it saw before it exceeded the context window. Easy peasy. Then, of course, our chunks are going to be small enough we don't have to worry about that. If they were big enough, we would worry about it and we would think about it, but they're not. They're nice and easy. We can embed and see that we get embedding vectors of 2048 for as our default, though this process does use matryoshka embeddings, which means that they can be whatever size we need them to be in order to optimize cost and performance. Next, we're going to talk about Quadrant. We use Quadrant because it's the best one. You have to make sure that this is, the size of our vectors are 2048. But other than that, it's just classic Quadrant. We just have to, spin it up. Okay, good. Then we're going to add our documents to our vector store with a UUID, as well as with some metadata that indicates what author they're from. This metadata will be leveraged by the LLM when it's producing a result. So it's important that we add the metadata here in order to get the best responses. That's just the way it works. And then, of course, we have the same thing, but for DaVinci. Okay. Next, we're going to create our retriever. This is kind of like where the most stuff happens, right? So our retriever should be a hybrid retriever using dense and keyword search, and then we should use re-ranking. You can use hide. Hide was found through a paper on surveying kind of like different RAG practices. Hide was found to be the most performant because with an additional layer of cost and complexity that I don't think is useful unless the performance of this default RAG pipeline is severely underperforming. Basically, what that means is that you can extend to hide if necessary, but you don't need to. If you're like, what the heck is hide? That's hypothetical document embeddings. Basically, what happens is we build hypothetical documents that try to answer the question, add those as context. Very, very fun. For hybrid retrieval, we're basically going to use BM25, BM25 classic. Never, no point to move on from the classics. And then I'm not sure what happened on my screen there, but it's back, and that's good. The idea is we are going to look at the top 5 from BM25 and the top 5 from our dense retriever. Our dense retriever is going to be that's going to give us a total of 10, right? 10 total contexts. And then for re-ranking, we're going to go down to the top 5. This is the compression we're talking about. So we go from 10 to 5. And then we go to the final, which is RAG prompt. RAG prompt is still important. I know it's like a meme at this point, right? Like this everyone's seen this prompt like 7,000 times. It still matters that you nail this, right? This is going to be model dependent, use case dependent, domain specific. You should spend time and effort here, right? Like your use case could be failing because your prompt is bad. And we don't want use cases to fail because prompts are bad. It's 2025. There is no excuse to have bad prompts. You just got to put in the effort. Okay. Then, yes, Black Current. We are in Cursor now. Okay. So Colab, dead to me. I'm kidding. We'll be back in Colab when we can. But for this, it makes sense to use Cursor. So we're going to do that, or VS Code, whatever IDE you care about. Then for our generator, we're just going to use Llama 3.3. 70B instruct as hosted through Together AI. We've already talked at length about why we're going to use this model. It's good. It's fast. We set temperature to 0. Classic RAG hack. Set temperature to 0. You should hallucinate ever so slightly less. Results inconclusive on whether or not this literally reduces hallucinations, but it certainly feels good. And anecdotally, it seems to have an impact on faithfulness, which is a proxy for hallucinations. Okay. Then we create a RAG graph. You'll notice that we have a RAG state, which is going to have question, context, and response. This is because we should always be returning context to users when they use our RAG pipeline. There is no more reason to, not provide context. The LLM will hallucinate. Even with the best RAG pipeline in existence, the LLM will still get it wrong sometimes, and providing the context helps users feel safe. It helps build trust. So we will always provide context to users when we highlight answers to them. We'll showcase how we do this specifically in part 2. But for part 1, just know we are absolutely always going to keep the context around. Okay. Then we have this retrieve thing. And there's a little Python syntax here that might not feel important, but it is important. So what we do is we retrieve the docs and then we return them in ascending order, which means that the least relevant is first in context and the most relevant is last in context. This literally has an impact on the system. You should always return them in ascending order. Just a trick that you should be doing all the time. Okay, and we can do it easily because LangGraph rocks. Then, of course, we have our generate. You know this one, generate. Good job. Okay, we're going to create our graph. Our graph is very simple because it's just simple RAG. We go from retrieve to generate. Our retrieve process, remember, contains hybrid retrieval and re-ranking. So this is like an overloaded, node. But the idea is that we do this process of decent retrieval and then we generate a response. You can see our graph looks like this. Now we can test it. We can ask questions like, why do birds sing? And we can get answers like, I don't know, because the quotes don't address the singing of birds. We can ask questions like, what did Da Vinci have to say about solitude? I don't know, because Da Vinci didn't say anything about solitude. Certainly not in the quotes that we have, right? And this is why the metadata is important, right? Because yes, Henry David Thoreau, check this out, talked all about solitude, right? But he ain't Da Vinci. So answering, if we didn't have that metadata, we might have tricked the LLM, right, into saying the wrong thing, but we didn't. It's smart enough, it knows. Then we can say, what did Thoreau have to say about solitude? And then we get the quote. And then we can synthesize, right? So both of them talk about perception or sight. So we can ask, what did Da Vinci and Thoreau say about perception seeing, compare and contrast response based on the provided context, yada, 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 yada. Thoreau's thought is more concerned with subjective interpretive nature of seeing, while Da Vinci is more interested in the technical and scientific aspects of seeing and perception, which makes sense given both of their backgrounds, right? The philosophizer philosophizes and the science man sciences. There you go. Okay. Then finally for evaluation, we go really hard on evaluation in a previous event. So in this notebook, we're just going to show a brief example of how we might evaluate. But please watch the RAGAS event if you want to go really deep in the weeds. Basic idea is that RAGAS is the best practice evaluation tool for RAG in 2025. There is very few substitutes that even come close. RAGAS is defining what RAG evaluation means in the industry. And so until that changes, we're going to continue to recommend them. You can see here that we can say things like, hey, is the question fully answered? And we get that from the response we saw about comparing and contrasting. Yes, it was fully answered. The question was done. There you go. That is our rundown of practical RAG in 2025. Again, I just want to highlight that this is the minimum. This is where you should be starting. If you start with less than this, you're missing the point, right? This is the bare minimum RAG setup in 2025. You are going to do more. You're going to need to customize it because your data is going to look different. Your connections are going to look different. Everything is going to be slightly different based on your use case. But this is where you should start. You should not use less than this in 2025. There is simply no more excuse. There you go. With that, we'll head back to Greg to learn more.
All right. Yeah, Wiz, I want to have a quick discussion with you. Now that we've got this thing going, we've got now this application that's up. We've got this application that's being used, presumably. I mean, you just used it a little bit. I guess when we're building, somebody's going to be using it. Hopefully more people will use it eventually. Then when we get into this space where we see usage now and we start to be able to look at usage, what should we be looking at specifically? Whether it's LLM serving and how quickly our inference endpoints are working, or the actual application in total, how quickly it's actually doing the retrieval augmented generation. What are some key metrics we should be thinking about right off the bat?
Yeah, 100%. We should be thinking about like how many tokens are we using? What's our average token, response, et cetera, et cetera. We should also be thinking about our latencies, right? What's our P50s and our P99s? These are kind of indirect measures of user experience. If we see that many requests are taking a very long time, that's bad. And if we see the long tail of requests are taking an extraordinarily long time, then something is wrong, right? In our system. This is going to change based on what kinds of models you're using, where your models are hosted, right? But the idea is that we want to be able to see into each portion of the stack in order to determine, okay, this is really wrong, right? The P99 is like 80% or 80 times slower than P50. Something is wrong.
Yeah,
right? Like, that's not good.
Right.
This is going to be very different if we say incorporate like a reasoning model, which have like extraordinarily high variance in response times. But for a RAG application that's just meant to be answering questions or a talk to my docs situation, we're absolutely most concerned with things like we have a very tight cluster of response timelines. We don't have requests that blow up the number of tokens we use for some reason. We really want to keep that down. And of course, errors are bad. Even if we handle them gracefully, errors are bad. Everyone trying to giblify their pictures using OpenAI in the last 24 hours is hammering the endpoint, so it's failing, and people are tweeting about it upsettedly, right?
Yes.
This is the classic. Like we have to know these things so we can choose when to scale up, how to scale it up, for how long to scale it up. Help build a forecast of our usage patterns over the last week, so we can continue to build a system that delivers excellent user experience without breaking the bank. The idea is we need insight to all of these metrics. We must have visibility and observability.
Well, yeah, and we need to know if people are asking the same thing, right? And then we can use some caching. We can use it to save some cache, right? We can make sure that we're not wasting resources completely. And one question is like, why? What is all this in the service of besides like the super hyper optimization? It's like one of the questions I just want to end on here is like, if we don't baseline and benchmark our compute and memory requirements, if we don't baseline and benchmark the user experience with latency, if we don't benchmark like what it is we want to be able to see when people are using it at a specific scale, how are we going to be able to choose the right tools and choose the right tools from the CSP who magically is going to solve all my problems? Exactly. How am I going to do that?
Yeah, you literally can't, right? So if you don't measure these things, you can't solution for them, right? Like you can guess, or you can get angry emails, right, from users, or you can read.
Classic. CSP is cloud service provider. Okay, guys, I want to go ahead and wrap with some conclusions in just a moment here. But I do think that, Wiz, you've got a little final demo of what you can walk us around, right? Sort of what it looks like to look at these monitoring metrics. Just a little brief glance that we can pick up in part 2.
Yes, we have just a tiny little
taster, a little zest to put on the top of the event here.
A little taste. Bearing that Chrome does not crash suddenly out of nowhere, we are going to look at this. We're going to look at this now. Rag and practice, Langsmith. Here we go. You can see it all. We've got our good friend stats. We've got tokens, cost, median tokens for responses, error rates, our P50 and P99 latencies. We can see exactly what's happening in our chain, exactly how long each section of our chain is taking, exactly where the most time is. You'll notice that our contextual compression retriever, which is our re-ranker, takes 1.06 seconds, where our ensemble retriever, which is our BM25 and vector store retrieval, takes 0.18 seconds. So our re-ranker is taking up most of the time in our retrieval pipeline. Classic, right? This is such a classic. Our generation is taking pi seconds, which is dope because it's fun. But obviously, we would prefer it to be as fast as humanly possible, right? 3.1 seconds is too long to wait. So maybe we should be streaming tokens out to users, right? We don't want to wait for 3.14 seconds to get a response. But if I spit these tokens out one by one in 3.14 seconds, it's going to feel nice. No one's going to read all of this in 3.14 seconds. So we're good. Let's just spit those tokens out one by one. This is the kind of insight you need to have in order to determine, right, what's going on. We can also look at classic at our waterfall. Big bar bad, small bar good, right? There you go. This is the base information you need. And then, of course, we have some dashboards you can create that track this stuff over time. But this is the base information you need to do anything useful, right? With the, with the actual application and making your user experience good. We can also see things like, okay, maybe we have people crawl through these answers, right? Provide feedback or metadata that shows us what went wrong, how it went wrong, right? We can have SMEs dig through this in order to patch holes in our system. All of this is just not possible unless we collect a big pile of data from people using our application. Like this one here. Why is this so dang long, right? Compared to everything else? Well, because the generation was really long. So, why was the generation really long compared to the others? We look at the run, we see, okay, this is a fully thought out response, right? Versus let's look at, this one, which is just going to be, if we go to our generate, right? Just going to be, very, very short. So it makes sense, right? Maybe we should add some kind of language in our prompt that says, keep it short, keep it brief, keep it concise, in order to help mitigate some of these issues or provide more standardization. In any case, you have to have this. It doesn't have to look like this. So it doesn't have to be Langsmith, but there has to be a big pile of all the stuff that your app has done so you can look at it, make decisions, and increase your user experience. Without this, the only way to get the feedback is from customers, which means they have to have a negative enough experience to tell you about it, right? Rather than just quiet quitting your app. They have to be so demotivated, right, that they whine to you, which is bad. We don't want that. We want to catch that before they talk to us, so we can proactively reach out and say, hey, we know the experience is a little weird right now. We're working on it. We're making it better, yada, yada, yada. There you go. That is back to Greg. Please don't forget to ring the bell. Subscribe. We're live every Wednesday. We love doing these events, and we'd love to see you guys in the next one. Back to Greg.
All right. Thanks, Wiz. So it's time to go ahead and conclude here, guys. We just saw Wiz operating some RAG in prod. And what we can kind of take away, I think, from today as a whole is there is a best practice stack if you're starting up. If you do retrieval really well, you can get very, very good results. If you constrain the results well, you can get very reliable results, as we saw. You need to make sure we're solving that core problem that we don't want LLMs hallucinating. We want to be able to put these things in front of our customers. We want to be able to create real value for people without creating headaches for ourselves. Once in production, we must start monitoring. We must figure out what is important to us, what's affecting the customer usage, what's affecting the customer experience. What do I need to be looking at? Once I know what I'm looking at, and then I have some estimate of the compute and memory requirements and the load I need, now I can start looking at cloud service providers. Now I can start thinking about the tooling. They're all sort of the same tooling, no matter on who you choose, but you can start to dial in what exactly do I need for this. And spoiler alert, in part 2, we'll talk more about sort of the multi-sequence. This might be round 1 build. What's the round 2 build as you get more and more buy-in from your leader in the enterprise? And then what ultimately is the integration build that you're, as an AI engineer, probably going to hand off to your engineering team. How can you make it easy for them? How can you make it so that they really respect at least your knowledge of engineering, even if not your implementation abilities? So stay tuned for part 2. We've only got a couple questions, I think, in the chat here, but let's go ahead and answer them, Wiz, today. There's one that was put in Slido, just double clicking in here. Why not use the recursive text splitter? Is this linked to the use case because we have the short citations? Specifically, what if we have longer sentences, paragraphs, etc.?
We should just not use it because it's general, right? It does not fit our data. There is some data that it can just fit, like Wikipedia data, right? But most of the time, it just doesn't fit our data, right? We know our data best, so we should provide the chunks. We should build the parser to turn our documents into chunks, right? Recursive character text splitter is literally just heuristics based on separators, right? We should just not use out-of-the-box splitters unless... I mean, no, period. We should just not use out-of-the-box splitters in 2025.
No out of the box splitters. You heard it here first, folks. Okay, so we got at least one question coming in here in the chat. How can we build in citations when we're doing streaming? Is there anything different we need to keep in mind for this versus the plopping out the final response?
No, that's it. Basically, once we have the full response, we should provide citations. You can stream those, like you can actually, because RAG is sequential, right? We retrieve context, then we generate. You can actually populate the citations first and then start streaming the response, or you can wait till the response is finished and then produce citations. At the end of the day, though, you should make sure you populate the citations. How you build it is more about UX and than it is about like technical soundness. So work with whatever teams you have to ensure that the user experience is coherent.
Okay. All right. Thanks, Wiz. That's a wrap for today, everybody. Thank you so much for joining us for RAG in Practice, the 2025 Best Practice Stack. We will be putting together a part 2 to tell you more about, once you have the startup, what are the sequence of steps from there you should be taking. We'll probably follow this same example. So join us for part 2. We'll put it in the newsletter soon. You guys will all be on it if you've come to this event. And if you're looking to keep the learning going, we did mention earlier, if you don't know about what's going on inside of the LLMs, inside of the transformers, then we have a great course we've just open sourced called LLM Engineering, the Foundations. You can definitely check that out directly on our AI Makerspace.io site. You can walk all the way through it from concepts to code and everything in between. If you're looking to really accelerate your learning, we've actually got some spots left in AI Engineering 6, the AI Engineering Bootcamp. This is going to be the most spectacular production of the bootcamp yet. We're always trying to improve. We've got a great set of peer supporters ready to support your journey all the way through, including some of them in the chat here today. We're going to talk about all of the details behind everything that we discussed today at a much, much deeper level. And we're going to go much wider and much further into AI engineering. So go ahead and get your application in today, complete the challenge, and start building, shipping, and sharing with us. Finally, you can find all of our events from RAGAS to more about LangChain and LangGraph to how does this apply exactly if I have agentic applications. We do this every week. We've got a great backlog of events from the past. They all have code attached to them. We've got great playlists. Check out our YouTube channel, and you can accelerate your search and retrieval process of finding the right thing by using the awesome AIM index. That's it for today, guys. Thanks again for joining us live on YouTube. As always, until next time, keep building, shipping, and sharing. We'll do the same. We look forward to seeing you guys next week. Thanks, everybody. See you soon.